Hello gang, so what we're going to be doing today is going over our chapter 1 review for our test, which will be coming up very soon. So let's go ahead and get right into it. We have number 1, find the property that each equation shows and write the equation in the correct box. Okay, so let's take a look at some of these properties. I know some of you guys are still having a little bit of trouble with this. So listen up and see if we can match some of these guys up here. So the first one down here is the identity property. Let me get a different, there we go. The identity property of addition. Remember that the identity property of addition it says that 0 plus any number is going to be that number. So that's going to leave us with 0 plus 16 equals 16. Okay? The next one is the commutative property of multiplication. Remember that the commutative property means that if you flip-flop the numbers, if you change the numbers around, no matter how you change them, you're still going to get the same answer. Okay, so when we look up top here, remember it has to have multiplication in it. And look what they did. They switched the 87 and the 3. So 87 times 3 equals 3 times 87. So that is going to be our answer for this one. All right, then we have the identity property of multiplication. Okay, remember the identity property with multiplication, the only difference is instead of 0 with the addition property, it's now going to be 1. So it's going to be 1 times 9 equals 9. Anything times 1 is itself. All right, so we have the associative property of multiplication. Remember, it's multiplication, so you're going to have multiplication in here. And associative means to group things, okay? We're flipping the numbers and we can group them then. So let's take a look here. Where's my multiplication? Let me go up a little bit more. There we go. So if we take a look at this one right here, you can notice that in the first one, they put parentheses around 7 times 9, and in the second one, they just moved the parentheses here. So that is the one that is going to be the associative property of multiplication. 15 times the product of 7 times 9 equals 15, the product of 15 times 7 times 9. Ran over a little bit here. All right. Then we need the commutative property of addition. So remember, it's going to be it's going to be addition, and the numbers are just going to be flopped. So if you look at the ones that we have left here, we have one of these two left. So in this case, if you look, we have 24, 4, and 109. And here we just have 4, 20. Did I say 24? I meant 23. 4 plus 23 plus 109. So all they did was flip-flop these two numbers. So that is going to work. That is going to be the commutative property of addition. So 23 plus 4 plus 109 equals 4 plus 23 plus 109. Here I am running over again. All right, and then the last one, that leaves us with the last one, which is the associative property of addition. So if we look, we have 13 plus the sum of 3 plus 7, which equals, just put this down here, 13. The sum of 13 plus 3 plus 7. Okay, so in the first one, they grouped the 3 and the 7, and then the second one, they grouped the 13 and the 3. So they just grouped them differently. Let me just move this back. There we go. And let me lock this in place so it stops moving on us. There we go. All right, let's move down to the bottom. Now, for problems like this in your book, where they give you true or false and there's 4 different ones, what I like to do in order to solve this is actually go ahead and solve those and see if they are true or false. It's the easiest way to do it. So the first one is saying 170 is 1/10 of 17. And remember, if it's 1/10 of, that what you can say to yourself is 170 is less than, because you can think a fraction is less than, because a lot of kids were mixing these guys up. So 170 has got to be less than this number. So that means it's not going to be 17. We're actually going to have to add a 0. So in this case, this is going to be false. All right, and the next one says 660 is 10 times as much or 10 times more than 600. Well, think about that for a second. If you have 660 and 600, that's not 10 times more. That's just kind of common sense if you think about it. So that one's also false. Oops, got a little crazy there. All right, 2C, 900 is 1/10 of 9,000. So you say to yourself, is 900 1/10 less than 9,000? Yeah, it is. That's true. All right. 4,400 is 10 times as much or 10 times more than 440. Did we just add 1 0? Sure did. That one's also true. Okay, let's turn to the page. We're on page 80, number 3. It says select other ways to write 700,562. Mark all that apply. Okay, so let's take a look here. We have 700,000, and then this would be 5,000. So if I put these two together, it would make 705,000. But this is actually in the hundreds, so A isn't going to work. 700,562. Yeah, that works. The next one, if we have 700,000 plus 500 plus 60 plus 2, that also works. If we have 700,000s, 500s, and 62 tens. Having some technical difficulty. Okay, and those 62 tens, that's where it's not going to work there. So that one is not going to work either. It shouldn't be 62 tens, it should be 62 ones. All right, let's look at number 4. Carrie has 140 coins. She has 10 times as many coins as she had last month. How many coins did Carrie have last month? Okay, so if this month she has 140, and we go back a month, so we want to say, okay, she had 10 times more this month than she did last month. Well, we'd have to take away a 0 off of that 140, and you're going to get 14 coins. And let me lock the screen again. There we go. All right, number 5. Valerie earns $24 per hour. Which expression can be used to show how much money she earns in 7 hours? Okay, so with this one, they're actually going to be using the distributive property, because what they did here when you look at these answers is they took that 24 and they split it into 20 plus 4 and then multiplied each of those numbers by 7. So if you look here, now look, we know it's going to be adding in the inside, so when we add them together. So we got to get rid of these two. Now we have to decide between these two. Well, remember, when we're doing this, we're going to be taking that 7 and distributing it and multiplying by the 20, and then adding the 7 times the 4, which is going to end up being this one right here. We would not be adding. We have to multiply. All right, let's go down to number 6. The table shows the equation in this Velez discussed in math class today. Okay, so you can see her equations in the chart here. It says explain the pattern of zeros in the product when multiplying by powers of 10. So look at the pattern here. 10 to the 0 power, no zero. 10 to the first, 1 0. 10 to the second, 2. 10 to the third, or 10 cubed, there's 3 zeros. Okay, so let me move this up a little bit. For each power of 10, the number of zeros is the same as the number in the exponent, and we've already talked about that. Okay, and if you need more time writing that, you can go ahead and pause the video so that you have more time to do that. Okay, we're going to bump over to number 7 here. 7 says it is 3,452 miles round trip to Craig's aunt's house. If he travels to her house 3 times this year, how many miles did he travel in all? All right, well, if he's traveling 3 times, we're going to actually be multiplying that. So over here, I'm going to write 3,452, and let's multiply by 3. You know that 3 times 2 is 6. 3 times 5 is 15. We need to regroup our 1. 3 times 4 is 12, plus 1 is 13. Carry our 1. 3 times 3 is 9, plus 1 is 10. And we go 1, 2, 3, comma. So our answer is 10,356 miles. All right. Our next one here, Lindsay earns $33 per day at her part-time job. Complete the table to show the total amount Lindsay earns. So in this case, gang, we're going to have to take that $33 per day and then multiply it by each of the number of days so that we can find the amount. So I'm just going to over here write my $33 times 3, and that's going to give you $99. Put my 99 in there. The next one is going to be $33 times 8. 8 times 3 is 24. Again, it's 24 plus 2 is 26. So it would be $264 here. And then let's do our 33 times 24. 4 times 3 is 12. We carry our 1. Once again, it's 12 plus the 1 is 13. Very important to make sure you put that 0 in there in your second partial product. 2 times 3 is 6, and 2 times 3 is 6. And then we need to add them up. 2, 9, 7. So, oops, no, wait a minute. Did something wrong here. Oh, because I wrote 24 instead of 14, Miss Hummel. Go back and fix it. No wonder. Let me write my 14 and do it again. So there's my 12, there's my 13, so that one was okay. But here's where I wrote a 2 instead of a 1. So don't forget your 0. 1 times 3 is 3, and then 1 times 3 is also 3. 2, 6, 4. $462. Now I got it. Get with it, Miss Hummel. All right, number 9. Okay, so they're saying Jackie followed these steps to evaluate the expression 15 minus the sum of 37 plus 8 divided by 3. All right, so she did Now remember, anytime we're doing this, you need to follow PEMDAS. Please excuse my dear Aunt Sally. Parentheses, exponents, multiply. Oops. Please excuse my dear Aunt Sally. There we go. Someone's got issues today. All right. So we started with parentheses. So did she start with parentheses? Yes. Okay. The 37 plus 8. Okay. And the other thing, you know what? When I do a problem like this, sometimes it's hard for me to look at the work and try to figure out if it's correct unless I actually do the problem. So I kind of work a little backwards on this one. Down here it says evaluate the expression. So I actually like to end up doing that first, and I write big, so I'm not going to be in this box here. Let me rewrite it. And let's actually do it, and then we can compare. So I'm going to bring down my 15 because we need to do our parentheses first. And that's going to give us 45. Then I just bring down divided by 3. Now I have subtraction and I have division. Well, division comes first. Please excuse my dear Aunt Sally. Division before subtraction. Okay, so 45 divided by 3 is actually 15. And then you just bring down your 15 and you subtract, and you're going to get 0 as your answer. Okay, so now we can go back up, and now that we've kind of worked the problem, we can kind of check it out here. So, and I like how we do our layers. She kind of put it like this, and it's a little harder to see with bringing everything down. But so, it's moving again. She did this one first, okay, and she got her 45. Then they took that 45, she's 45, and she subtracted 15 from it, okay, which that is not correct right there, because look what we did down here. We have to do the division first, and that's where she made her mistake. So it says, Mark looks at Jackie's work and says she made a mistake. He says she should have divided by 3 before she subtracted. Which student is correct? Well, we just figured it out. Mark is correct. And explain how you know. Well, let's do this. Order of operations. Says to divide before subtract. Okay? All right, let's move on to the next page. All right, number 10 here, gang. Let me try to lock it. All right, so Carmine buys 8 plates for $1 each. He also buys 4 bowls. Each bowl costs twice as much as each plate. The store is having a sale that gives Carmine $3 off the bowls. Which numerical expression shows how much he spent? I kind of just like, when I do something like this, I kind of just like to do it. 8, I write it out. So 8 plates for $1 each. It's going to be $8 times $1. I mean, 8 plates times $1. And then he also buys 4 bowls. So we know we're going to do that. Each bowl costs twice as much as each plate. So it's going to end up being 4 times 2, right? But then it says that there's a sale and there's $3 off. So we're going to end up subtracting 3. But you need to be careful because you have to, if we would solve that first and we wouldn't do this, we would end up getting a different answer. So you have to end up putting brackets around here so that you do this part of it first with 4 times 2, and then subtract the $3, and then add it to the 8. Okay, because the sale is only $3 off the bowls, not the plates. So that was a little tricky. But that would end up being then letter C. Okay, 11, evaluate this numerical expression. So we know parentheses comes first. We're doing PEMDAS. So we have to do 65 plus 7, which is going to give us 72. We just bring down our 2 and our 3, multiply by 3. You know multiplication you need to do before addition. So we need to do 72 times 3. So if you need to, you can do this. So you have a little more space. That equals 216. Plus the 2 is 218. Number 12, an adult elephant eats about 300 pounds of food each day. Write an expression to represent the number of pounds of food a herd of 12 elephants eats in 5 days. Now be careful here, they just want an expression, so you don't have to find the answer, they want the numerical expression. So what we could do here is 300 times 12, because there's 12 elephants, right? And then they want to know how much in 5 days. So then you multiply that answer by 5. Now, did anyone do this? If you did, that's also correct too, because you can have it either way as long as your 300 and your 12 are in parentheses. 13, Jason is solving a homework problem. Ariana buys 5 boxes of granola bars. Each box contains 12 granola bars. Ariana eats 4 bars. Jason writes a numerical expression to represent the situation. His expression was the difference between 12 and 4 times 5 has a mistake. Explain Jason's mistake. So in his, he should have actually multiplied 12 by 5 rather than subtracting 4. So he should have actually done 12 times the 5 and then subtracted 4. Okay? Because in that case then there's 12 in each box and there are 5 boxes. But she ate 3, so that's your subtraction. So that's going to make 12 times 5 minus 4. So on here, if we explain that, we can say he should have multiplied 12 by, got a little crazy, by 5 rather than subtract 4. Okay, and then you can even write he should have had, and you can put this down. Okay, and then they want you to solve this equation. Write an expression to show how many granola bars are left, and then solve it. So we already did that. We did 12 times 5 minus the 4. 12 times 5 is 60, and if we subtract 4, you're going to get 56 granola bars. Okay? We are going to, well, we're missing a page here. I don't know where it got to. There it is. Okay, we're going to actually skip 14, 15, and 16. You know what, let me go back because there is one at the very bottom here we're going to do. We're going to look at number 17 because they want to know if Jeannie eats 1,840 calories a day. How many calories will she have eaten after 182 days? So this is a big problem. I'm going to start up here so I have enough room. Maybe move up a little. 1,840 times 182. Okay? So 2 times 0 is going to give us 0. 2 times 4 is 8. 2 times 8 is 16. We'll carry our 1. 2 times 1 is 2 plus 1 is 3. We drop our 0, cross this off. If you want to cross that off too, you can. Let's move to our tens. 8 times 0 is 0. 8 times 4 is 32. 8 times 8 is 64. Plus 3 is 67. Carry our 6. 8 times 1 is 8. Plus 6 is 14. Okay? Cross this guy off so we don't get messed up. Cross off the 8 if you'd like, because this is a long one. Now the next one, since it's in the hundreds, you actually end up having to do your 3 zeros there. No, 2 zeros. My bad. Because up here it was 2 just because we multiplied 8 by 0. So we did our 1 0 here, and you need 2 down here. So now 1 times 0, you're going to end up having another 0 because 1 times 0 is 0. 1 times 4 is 4. 1 times 8 is 8. And 1 times 1 is 1. We go ahead and we can add those up. And we get, oops, Miss Homo, 1, 2, 3, comma, 334,800 calories. 880 calories. I don't know if that's what I said, but that's what it is. All right, so let's go to our final page here. 18. There are 8 teachers going to the Science Museum. If each teacher pays $15 to get inside, how much did the teachers pay? Well, that's a multiplication problem. We'll do 15 times 8, and we get $120. And they already put the dollar sign there for us, which was nice. All right, 19, select other ways to write 50,897, mark all that apply. Okay, so if we look here, this is 50,000, this is 897. So this is going to work. Your next one is 50,000 plus 800 plus 90 plus 7. If we put those together and we write them up and down and add them, that's going to work, which means this one isn't going to. And then 50,897. That's also correct. So there were 3 this time. All right, so number 20. For 20A, what we need to do in this case, once again, like I said, if it's a true or false, what I like to do is actually just solve the problem. So I'm just going to rewrite it over here. 55 minus the sum of 12 plus 2. And they're looking at a value of 41. So let's see if that's what we get. We have to do our parentheses first. So we're going to get 14. Bring down our 55 minus 14. And we are going to get 41. So that's true. All right, then our next one is 25 plus the difference between 14 and 4 divided by 5. Let me just erase this so we don't get confused. All right, so we have to start with our parentheses. So let's just bring our 25 down. 14 minus 4 is 10 divided by 5. Okay, remember PEMDAS. Please excuse my dear Aunt Sally. You have division. We need to do that before we do addition. So we're going to put 25 plus, and 10 divided by 5 is going to give us 2. 25 plus 2 is going to give us 27. So they have a value of 27. So that one's actually true also. All right. And then number 21, Tara bought 2 bottles of juice a day for 15 days. On the 16th day, Tara bought 7 bottles of juice. So they want an expression. Once again, expression. We don't have to solve it. We just need the expression. So 2 bottles of juice for 15 days. And then on the last day, she bought 7. So we're going to multiply the 2 times the 15, and then we'll add the 7. There's your expression. Okay, our last one, select two other ways to express 10 to the second power. Mark all that apply. Okay, now be careful. Many of you have been just multiplying those two together. Please do not do that. Your math teacher will, she'll cry. Don't do it. Because remember, this would be like doing 10 times 10. Remember, you can say 10 multiplied twice is a good way to say it so that you remember. It'll help you remember. And you know that 10 times 10 is 100. So B is going to work. And look, we already did this one here. Letter F is also going to work. The rest of them are not going to work because they all equal either 20 or 12. And it has to equal 100. Okay? Well, this was your review. If you have any questions, let me know.